Okay, so the first part of this talk is about what happens in scenarios of causal loops or grounding loops or some other kind of dependence loop. And the connection to black holes is that, as Nick was explaining just now, black holes of certain distinctive varieties, not your regular black hole, but certain kind of rotating black hole solutions to general relativity seem to feature closed time-like curves. And these things are naturally interpreted as causal loops. And one of the popular accounts of causation, interventionism, doesn't seem, at least in its kind of familiar canonical formulations, to have a particularly good account of causal loops. I mean, this is an account of causation that's been developed in the context of like experiments and interpreting statistical data that's got from like either experimental interventions on the world or just from like observational studies. And the aim is to make inferences about causal structure. That's the way interventionism most often gets used. But it can also be used to account for, to kind of explore more general structures. That's what I'm doing here. And I really just want to kind of float a few possibilities for what happens when you start thinking about causal loops in the interventionist style way. And I'm sure there are people in this room that have thought more than me already about this sort of thing. And so really this is just, I'm kind of looking for input. Where should I go next with this? What should I go and read? Should I kind of, is there some kind of presupposition to this project that's misguided? So I'm going to imagine that we've got like a loop of variables. So interventionism is representing facts with variables that can take different values. So like different values of the variable correspond to different facts. So I have in mind a situation where we might have A, B, C, D. I think that will be enough for now. And the normal idea would be that we have directed dependence between these variables. This is a closed time-like curve. That is, it's time-like. That is, there's a kind of direction, the time-like forwards direction, which is associated with one direction but not other around this curve. And as you might expect, it's going from A to B to C to D, and then back to A. That's what makes it a closed curve. And let's just set some kind of equations up for this. The way I'm thinking of interventions working, it uses structural equations. So it uses some equations that link the values of these variables in a functional way. So we're thinking, for example, that when we write B equals A, what that is saying in this context is we're meant to read that equal sign in a directed way. B is kind of identified to have its value as what it is, as a function of A's value. So B is being kind of determined here in terms of A. That's the way to read that. B is a function of A. And then likewise, C is a function of B, and D is a function of C, A is a function of D, and so on. So you can see immediately that there's going to be certain ways of like consistently assigning values to all these variables. Assign all those variables a value 0, and that works. Assign them all a value 1, and that works. In fact, you could assign them any value you like, because they could have like a spectrum of values. So what this system of equations is telling you, it's like you might think naively, there's one consistent way of assigning that. There's many consistent ways of assigning values to these variables, but all of them assign the same value to all the variables. So far, so good. We've got some kind of like consistent histories here. But interventionism doesn't just characterize things in this way. It characterizes things via interventions. And in part, what it is according to interventionists, for dependency to be causal is that we're meant to be able to make an intervention on some variable, and then that intervention kind of gets carried along downstream. So suppose we set these all to 1, but then we add, I'm going to change my I to an intervention variable over here. We add a new variable into the system, as interventionists often do, and we imagine that that's an intervention on A. And if, depending on what the value of the intervention variable and what the intervention relation is, there's a few different kinds of results we could get. I mean, one kind of thing we could do is the following, is to say that the intervention just kind of completely destroys that connection, takes it out of reality. And then we get no interesting results. And maybe all of this relies, and this is one reason why I got worried this wasn't going to go anywhere, to rely on like a non-standard version of intervention in these contexts where that thing doesn't get broken, but gets modified instead by the intervention variable. Because, I mean, on the way of thinking about it where that connection there just gets broken by the addition of the intervention variable, what we've done by intervening is to kind of make this not a causal loop scenario anymore. But we want to understand it as a causal loop. And so here's a few things that might happen if you were to kind of add an additional input onto A without completely eliminating the connection between A and D. Suppose that what you have is that so if I is set to 0, the intervention variable has no effect. But if I is set to 1, then A is now a function of I and D. So instead of A being just a function of D, we could have A equals D minus I, and put that in modulus, take the modulus of that. So now if I is 1, if I is 0, nothing happens. The equation is just reduced to the same form as before, so we just have a causal loop again. But if we set I to 1, now A gets set to 0. And then, continuing as interventionists do to trace the influence of the causal effect around the chain, B is a function of A, B becomes 0. C becomes 0, D becomes 0. But given the way I've got A is the modulus of D minus I is still 1. So 0 minus 1 is minus 1. The modulus of that is 1. So A has been now set back to 1 again, having gone around the loop again. Keep on going round. On the second time round, I remains 1. Now D is 1 again. That sets A to 0 again. So we can travel repeatedly around this loop. And what's happening is that A, B, C, and D seem to oscillate each time down the loop. They kind of all set themselves to 1, then they all set themselves to 0 again, and they all set themselves to 1 again, and they all set themselves to 0 again. So you have this kind of oscillatory behavior of the values of the variables as you travel around the causal loop. And really, kind of all I want to kind of note and kind of flag and put out for discussion is that there's a kind of few different, it seems, there's a few different structures you could have here. You could have one where, I mean, the intervention has no effect, it's a trivial one. You could have one where the intervention sets these to 0, but then they stay at 0 forever as it goes around. Or you could have one of these oscillatory behaviors. Or if you make an instant, sorry, I'm pressing the wrong screen. If we change that minus to a plus, then A is going to start out at 1, therefore B's 1, therefore C's 1, therefore D's 1. therefore A is 2, therefore B is 2, therefore C is 2, D is 2, and so on. So again, we get, like the oscillatory solution, we get a result where each time around the loop, the variables hop up 1. And so we never get any repetition of the content of the loop, but we do get it being different on each iteration around the loop. So there's a kind of at least 3 kind of structures. There's the one where the intervention doesn't change anything. There's the one where it 4 different structures. There's one where it makes a change and then that change is permanent. There's the structure where it makes a change and that change oscillates back and forwards. And then there's one where it makes a change and that keeps on iterating so that the variables just keep on climbing indefinitely in value. And prima facie, these look like 4 different, like if you interpret that causal loop, if you interpret this this loop as like a physical history, those are 4 different like ways things could physically be on a causal loop, depending on what sorts of interventions you make. So really, that's what I have to say about this sort of scenario. There was going to be a fair bit more, but when I went back and looked at my slides from when I gave this talk a few years ago, the fair bit more relied on a theory about the difference between grounding and causation that I now would reject and repudiate. And so turns out most of the additional interest beyond there of the talk I'd written before has now evaporated. So that's, I guess the last thing I will say is maybe to kind of distinguish between 2 sorts of explanations here, the kind of local, the kind of explanation of local behavior and the explanation of global behavior. We want to say, I think, that like in each case, the explanation of each variable taking the value that it does is its immediate ancestors. I think that's kind of something we definitely want to say. But it looks like whether we have, which type of behavior we have, whether we have no change, a change that is permanent, a change that leads to oscillation, or a change that leads to kind of endless, ongoing change each time around the loop, those 4 different scenarios, those are to be explained not locally, but globally. So it's like features of the whole network that determine whether that's the case. And you could change like individual ones of the links, their character, and change the character of the whole. But nonetheless, it seems like the whole is the appropriate level of explaining for what sort of behavior you have, whether you have oscillation or static behavior, for example. So there's this kind of one takeaway is that there's a kind of 2 sorts of explanatory levels here. There's the explanatory level of explaining individual variables versus the level of explaining the behavior of the network that consists of all the variables. So I don't think any of this is particularly surprising. I'm sure people that have spent time thinking about time travel will have had thoughts that at least overlapped with some of the things that have come out here. But I would just be interested in pointers, in suggestions, kind of ways to take this that don't rely on this doomed connection with classifying grounding and causation. My current view, well, last thing I would say, it's kind of easy, especially in the closed time-like curve kind of scenario, to think of these as causal loops. And my worry was that via my old criterion for what the difference between causation and grounding was, that these individual loops, these individual links might end up counting as grounding because of like non-contingent features of the whole network. My new criterion for distinguishing them doesn't have that feature, but nonetheless, the thought might be that we have a kind of causal kind of explanation of each variable in terms of the other, but maybe we have something like a grounding explanation of the behavior of the whole loop, whether it's oscillatory or not, for example, in terms of something else, features of the whole loop. So maybe that's the sense in which grounding and causation get kind of intermixed in this situation. Okay, so that was the first part of the talk. I've been going for what looks like about 15 minutes. So I'm going to talk for another 15 minutes about something completely different. And here, I'm going to temporarily blank the screen because I'm going to bring up now I've got my computer plugged in anyway, it's going to be easiest to bring in a slide here from a different talk, I'm afraid. So about 20 seconds it will take to bring up this slide. Okay, so how do I share screen? Share screen. So this, I think it's coming. Oh no, do I need to, I'm blanking, I do. This is a different talk, but in discussing the grades of modal naturalism, and in writing a book on this, a Cambridge element on modal naturalism, if we can't think of a better title, that Amanda Bryant and I are currently halfway through writing, we talk about modal naturalism, that is the view that science should bear evidentially on the modal facts, that is, which things are possible and impossible, broadly speaking. It turns out that black holes are a particularly interesting example of, potential example of naturalization of the modal facts, of scientific input into the modal facts. And we're kind of considering using it as the lead example. And so I'm now here hoping to get some feedback on the concept of black holes playing this role of serving as an example of how science can tell us about objective possibility and necessity. So jumping quickly through a load of these slides, because there's really a lot of here that we don't want. I mean, look, there's a black hole being an example right there. Where's my statement of the grades? Here we go. This is the slide that is kind of, we're going to be using. So here's 5 different grades, plus a thing that is a non-grade, because it doesn't even get started, of how seriously science might bear on objective modality. Grade 0 say it doesn't really count, it's not a grade, because it says there's no such thing as objective modality, so there's kind of nothing there for science to bear evidentially on. Grade 1, and I think this wouldn't normally be counted as a particular type of naturalism about modality at all. It's kind of such a low grade that it's effectively not naturalistic, but it is like the bottom, this is the bottom position on the rung, on the ladder. And this is the view that scientific evidence will tell us what's nomologically possible, or will bear on what's nomologically possible, what's physically possible, indeed what's biologically possible. But it isn't going to bear on some underlying space of metaphysical possibilities, which are seen as objective and as immune to empirical confirmation or disconfirmation. Grade 2 is where it starts getting interesting. And I've divided grade 2 into 3 different grades. So the 2A, 2B, and 2C. 2A says they're all about scientific evidence bearing on the background space of metaphysical possibilities. Not just bearing on like which of these is actual, but on what the background space of metaphysical possibilities is actually like, what real metaphysical possibilities there are. And grade 2A says scientific evidence can expand, rationally expand that space. That is, we can have like objective reason to believe, based on some scientific evidence that comes in, that the background space of metaphysical possibilities is larger than we thought it was. More things are possible in heaven and earth than we had previously imagined. And I want to say black holes are a clear case of this. They're a case of this kind of several times over. They're a case of this because they involved curved space-time. I would go so far as to say they can't be understood without curved spacetime. And curved spacetime is something, a kind of classic example of something that was previously widely believed to be metaphysically impossible. I mean, you can imagine, one way of reading Kant is as having argued systematically that curved spacetime is metaphysically impossible. I know there are Kantians out there that don't think Kant argued that, but that is like a very common reading of Kant. And I think it's, it wouldn't just have been Kant that would have said curved spacetime is impossible, genuinely impossible, if you had asked a few hundred years ago. It was really something that I think would have been regarded as a pretty clear case of the metaphysically impossible, insofar as you could have communicated with people from a few hundred years ago using this language. But it's not just the fact that it has curved spacetime. Like I think probably the view of people that had incorporated curved spacetime into their worldview as a possibility enough to like incorporate GR were still genuinely surprised when these models with singularities turned up. I think the expectation had been that all models of GR would be like reasonably well behaved and that they wouldn't have singularities in. And it was something of an unpleasant surprise when these models turned up in the first 10, 20 years of the history of GR. I'm not an expert on the history, but that's my understanding of it, that they weren't immediately spotted, these solutions. Indeed, black hole solutions weren't immediately spotted, but it took a further observation to get the type that features CTCs, post-harmonic curves. So, so I think there's at least kind of three different ways in which you might argue that the existence of black holes, the scientific evidence that has led us to posit black holes, has ipso facto led us to revise our view about metaphysical modality. I think that it contains space-time curvature, that space-time can be curved is one such thing, that it can be infinitely curved as it is in a singularity, and also this further thing that it can then lead to closed time-like curves that have also been thought of as metaphysically impossible at various stages. And it doesn't need to be that everybody believes this to be metaphysically impossible, just that like some people, there were some rational belief states that went from regarding this stuff as metaphysically impossible to regarding it as metaphysically possible in light of this sort of scientific evidence relating to black holes. So all of that is grade 2A. Maybe there are further features of black holes that could be argued to be the kind of thing that would have been regarded as metaphysically impossible at various stages of previous scientific development, but I think at least those three are legitimate. Grade 2B is kind of, in some sense, the inverse. Kind of have to pose this carefully. Basically, what I'm thinking of grade 2A is kind of adding possibilities, new possible worlds that weren't previously regarded as genuine possible worlds. Grade 2B is about getting rid of possibilities. It's not just about adding necessities, because of obviously dualities, those kind of go together with negation, but the idea of grade 2B is that things that people previously thought of as genuine possibilities turn out not to be. And this is obviously going to be more controversial. This comes in two versions, this sort of contraction view. But just staying at the kind of more modest version, this is the kind of thing that dispositional essentialists say. When they say, we've discovered that for example, one thing some essentialists say is that salt necessarily dissolves in water. No. Ipso facto, you can't have some salt that doesn't dissolve in water. There is no possibility that one has salt that doesn't dissolve in water. And that looks a lot like the kind of things that one intuitively says about black holes. Once you fall in, you can't get back out. And again, I think there's kind of numerous kind of impossibility claims that could be supported by the physics of black holes. But that matter can't like travel from one side of the event horizon to the other I think, is, sorry, put it that way, can't travel from the inside of it to the outside. I think that is a straightforward case of impossibility that has a good claim to be a metaphysical impossibility. It's kind of two senses in which it might be metaphysically impossible. One sense in which kind of any trajectory that was from like the inside of a black hole to the outside couldn't be a matter trajectory, or it couldn't be a trajectory in space-time. That would be the kind of way that dispositional essentialists might like to put it. They say like anything that doesn't dissolve in water just couldn't be salt. Maybe there could be something that was salt-like, that tasted similar to salt, for example, and looked the same, and that stuff doesn't dissolve in water, but salt necessarily dissolves in water, and anything that doesn't dissolve in water can't be salt. Likewise, you could say that maybe there are kind of things like black holes that matter can escape from, but those things wouldn't really be black holes. I'm not as excited about grade 2b as I am excited about grade 2c. Grade 2c says there are limitations on what can happen that aren't just like limitations on what can happen that derive from what counts as what. So it's not just a matter of salt being sodium chloride, that salt can't dissolve in water, that salt must dissolve in water. It's because maybe there are no worlds where there is anything salt-like, whatever it actually is, that doesn't dissolve in water. Or kind of more generally, what this grade says is that not only can't matter escape from inside black holes, but there are no possibilities anywhere in the space of metaphysical possibilities which are kind of close enough counterparts of matter escaping from black holes at all. Like there's nothing that is even kind of in that vicinity out there. So there just really are no metaphysical possibilities that even have the structure of matter escaping from a black hole. And insofar as we think that the relevant physics is telling us about the nature of space and time and matter, I think we might be inclined to go for grade 2c. Insofar as we think it's telling us about like what really can happen in any physical world, it takes us to grade 2c. But grade 2c involves like a fairly strong necessitarianism about the laws of nature. There are not very many people that go to grade 2c. People go there are people like Stephen Leeds, I think John Heil, Dorothy Edgington, me. There's just only a few of them out there. Whereas this is a much more widespread view, this more dispositional essentialist style view, that doesn't put limits on the structure of modal space, but just on kind of what particular properties can or can't do. And then there's a heavier duty grade that is where things get really naturalistic, but that's actually not relevant, I think, to what we're doing, except, I mean, there are some connections to some of the things that Baptiste was saying about whether we think that what we think is going on in the center of a black hole, whether it's a case where kind of space has failed to emerge. I think there are interesting things to, maybe some interesting connections there. But broadly speaking, I'm thinking that black holes are potentially strong examples of these grade 2A, 2B, and 2C types of modal discovery. And perhaps they are indeed some of the least controversial examples of that. So basically, yeah, I'd be interested to hear your thoughts on the extent to which scientific discovery of black holes has amounted to scientific discovery of like important facts about metaphysical possibility in general. Right, I think that's it. Thanks for patience with that slightly disjointed talk.